Okay, so for this question, for question number 1 on the exam, maybe it'd be better if I just showed it here. So this is basically question number 1, is this portion. So they give you this anchor setup, they call it the death triangle, and there's 2 anchors here with a force between them, the tension in this rope between the 2, and then the tension from this 80 kilogram climber that's rock climbing, and it's at a 70-degree angle. They basically want to know the final force acting on each anchor, and it's going to be symmetrical. So if you find the force for one, you'll find the force for the other. And they want to compare that to the force of the same thing, but without the line in between. So this is kind of my drawing I did. Sort of the same thing. I basically split this into 2 equal triangles. And so this would make this 35 degrees, right? So I know that the tension in the Y direction, because the question doesn't say this, but I'm assuming that it's in static equilibrium because it's saying that the climber isn't moving. So I'm assuming that they're in an equilibrium here. So I know that the tension in the Y direction has to cancel out or be equal to the force, or not the force, the weight. So 80 kilograms times 9.8 gives me 784 newtons. So I know that the tension in Y has to equal this if this guy is not moving. So I did my sum vectors, ty1 plus t2y minus mg equals 0. And I added those over and then basically combined those and divided by 2. So the tension for each one of these ropes in the Y direction should be 392 newtons. So taking that, I know this length basically, and I know that this is the angle is 35, so I'm going to use some trig functions to basically find out my x value and my hypotenuse, which would be the tension in this rope here. So doing that, cosine of 35 is equal to the opposite over the adjacent, opposite over hypotenuse. Rearranging to solve for t, I get 392 over the cosine of 35 is 478.5436 newtons. That should be my tension in this rope here, okay? So similarly, now that I found that, I find the tangent, which is opposite over adjacent, t of x over 392. Rearranging the same way I did for that, you get t of x is equal to tangent of 35 times 392, so you get 274.48. And that should be my tension in the x direction, right? Now that's identical, so it'd be the same for the other side of this triangle as well. It should be the same values, right? So this is just making sure my work is right. So I did Pythagorean's theorem, did a squared plus b squared is equal to c squared to find the same answer, 478.54, which is what I got here is 478.54 newtons. So times that by 2 should be 957.086 newtons for the tension in these 2 ropes, right? In this direction. So the tension from this rope on that anchor alone and this rope on that anchor alone is 900 so-and-so or whatever, right? Now, you have to find the sum. And this is where we do an entirely different situation to find the tension for this line here, right? So that I just said was the sum of the 2. So let's just keep it at 1 so it's not super confusing, but I'm just going to say the tension on an anchor in this direction is 478 newtons, right? That's what we solved for. So now I'm going to draw another free body diagram essentially and solve for the tension here for this guy and that rope. And that's going to look like this. So if that's my anchor, that's 35-degree angle, and this is 90, so that must be 55 to get it to be 180. So that being said, I don't have any acceleration in the Y direction, and I'm not concerned about that, but the sum of the forces in the X direction is equal to, and I just called this line P and this one M, just to keep things straight. P plus M sine theta should give me 0. And so the sine of this angle of M is going to give me sine is opposite over hypotenuse is going to give me this number here in that direction, in the y direction. So I solve for p. P is equal to m sine theta. And then to figure out what the p-value is, we're looking at it like this. The m is, why did I put 478? Hold on, I'm trying to remember why do I have 478 here for the m? Oh, duh. It's the Newton force I already figured out here. Or up here, yeah, 478.54. I already figured out that angle. Jeez, it's been a long day, sorry. This is getting super long. So 478 sine of 55 is gonna give me the p-value, which is 391. So I'm basically saying there's 391 newtons of tension or force in that line in the x. So if I combine that along with the line of the 478 in this direction, so I'm saying 391 newtons of tension in this rope here, 478 newtons of tension in this rope here. So on this anchor alone, I would have the sum of those, which is 900, no, where is it? Which is right here, 869 newtons. So basically that's saying there's 869 newtons of tension on each anchor point when an 80 kilogram climber is suspended by this system, right? So that's actually terrible because that's an incredible amount of force that's on the anchor. So the second part of the equation is to figure out, and this is my other picture here, the tension of it in just one rope, right? And this is why climbers will use this configuration more. And we already solved for that in the first step up here, but to sum it up again, we basically have each rope has a force in the y direction, and the sum of the forces in the y direction, which is 2 times the tension of that, is equal to the weight, which is mass times acceleration. And so to solve for it, you end up finding it's 392 newtons of force. So there you go. Oh, no, sorry, that's in the y direction. We want to find the hypotenuse. So we come down again, we do the cosine of 35 because we split that in half. And the cosine of 35, we're going to isolate for t equals the ty over the cosine of 35, which is 392 over the cosine of 35, gives me 478.5 newtons, which is the same amount of newtons I got when I solved for it up here for the death triangle. So, and then to compare the ratio of the two is right here. So I'm saying I have 869 newtons in the death triangle, but only 391 newtons of force acting on this anchor if I don't have the rope connecting here. So if we use the death triangle as opposed to this open V, you have 2.22 times more force on an anchor, which if you're rock climbing and suspended above the ground is obviously a bad thing, so you don't want to deal with that. So it's better to not use this setup and to use a setup like this. And that's kind of a long video and all over the place, but hopefully that all makes sense. And I think that's the right answer.